Chapter 3, Section 5, Question 1, point slope form. For those of you going into a PPCC math class, point slope form. This formula here is very important. It's also a formula that many students forget as they get to their midterm and final in this class. So, we actually have a way of deriving this formula, meaning figuring out where the heck they got that from. Do you remember our slope formula? And you might ask, hey, why is the m equals on the right-hand side? There's a reason for that. If you look, the y's are on the left-hand side and the m is on the right-hand side. I'm thinking ahead. We're going to make our common denominators. We've been doing this since chapter 2. We're going to continue doing this into chapter 6, and this is really going to help you with chapter 6. Common denominators and an equal sign. Act like little laser beams. Pew pew, they're gone. And we have y2 minus y1 equals m parentheses x2 minus x1. Ta-da! But wait, what happened to these 2's? It's called point slope form. You have a point and you have a slope. So here is our only point, our one point. We don't have a second point. It's just that. This is how we got that formula. This is the formula we need to use. So try and have that memorized. If you don't have it memorized, this is how to recreate the formula. Point slope form. A student told me that point slope form, often abbreviated as P-S, also stands for plug and stop. So we're going to plug and stop. We have y minus the y number. This is our x number, this is our y number. It's our first x and our first y number. Y minus the y number equals m, which is 3 over 2, parentheses x minus the x number. Now, take a look. I did not do plugging in and then simplifying. Over here, x minus negative 5, I am okay with you guys simplifying here. So I talked to one of the PPCC professors, and I said, do we need to put x minus parentheses negative 5 parentheses, and then simplify it to this so that we can plug and then simplify? And he said, in this case, no. So hey, if they do not need you to plug and then simplify, I do not need you to plug and then simplify. This is a perfectly good answer for point slope form. Now, how do students get this wrong? It seems so easy, we just plug things in. Students see this, they remember the distributive property, which we've been working on since chapter 1. They start distributing it, and then it becomes wrong. Don't do it. All right, so I boxed this answer, and there's a lot of space before you get to slope-intercept answer. There's a reason for that. I want to then, as I work towards getting my slope-intercept form, I want you to think about that impulse of students to use the distributive property. In chapter 2, we actually got rid of the common denominators and then distributed and solved for y equals mx plus b, which is what we're doing here. But I want to see if, at this point in our math, can we just add over a 2? We'll need to have common denominators, and these will cancel, and we'll get y equals 3 over 2x plus 15 over 2 plus 4 over 2 gives me 19 over 2. That is our slope-intercept form. Chapter 3, Section 5, Question 2. Hey, it's our old friend, the slope formula. And if you remember, I would like to see plug, work, and answer. Or actually, formula, plug, work, and answer. Here we go. Formula. Plug. This is our x and our y. This is our x and our y. This is our first x and y. This is our second x and y. So y2 minus y1. I'll let you do the minus negative here as well. 5 minus 3. And this gives us 7 over 2. And we can actually just leave it like that as 7 over 2. All right. And then over here, formula, plug, work, answer. And students say, I just wrote the formula there. Why do you want me to write this again? It is because I do not want you to lose out on $700 if you mess up in your 121 class and end up having to pay for it. X and Y, X and Y. First X and first Y, second X and second Y. So, plugging in Y minus -5 over X minus our X. And we get 2 and -7. Here we could actually go with -2 over +7 because we don't usually have the negative in the denominator. Now, first we have to find the two slopes. Remember, when you're finding the slopes, we do want to have our m equals on the left-hand side. Take a look, all the m's are all lined up, all the equal signs are lined up. Same thing here. We want formula, plug, work, answer. In this case, since we couldn't reduce that, that's fine. Determine if they're parallel. Now, these two L's in parallel remind us that parallel lines have the exact same slope. So are they the same? Perpendicular lines meet at 90-degree angles, often notated like this, 90-degree angles, and what's going to happen is it's going to be negative reciprocals. Negative reciprocals, or you can tell if it change sign and flip. So if we change the sign and flipped it, then let's take a look. 7 over 2, 2 over 7. Positive, negative. Change the sign and flipped it. They are negative reciprocals of each other. These are perpendicular. If it's not exactly the same, or if it's not a negative reciprocal, let's say it's just negative. Let's say it's just a reciprocal. That would be neither. At this level of math, we are trying to trick you. So you might think about previous math classes. They might have given you 7 over 2 and 57 over 84. And then say, hey, does that work? So we're going to be a lot more subtle about it at this level of math, preparing you for your college class. Chapter 3, Section 5, Question 3. Again, parallel, perpendicular, or neither. Solve for slope-intercept form. You'll remember that these are called standard form. They have x's, y's equals number. Back in Chapter 2, we were solving these for slope-intercept form. Same thing here. So we're going to take our equation, and we're going to solve it for y. Negative and negative makes it positive. Positive and negative makes it negative. Now, did we solve for slope-intercept form? Yes, but they're going to ask you to find the slope on your homework. So we're going to have to find the slope. Remember descending order by degree? Wow, look at all that reducing we're going to have to do. Negative and negative is positive. That reduces to 2/3. Positive and negative is negative, and that we can divide top and bottom by 3. Gives us 3 over 2. And we have to find our slope, which is 2 over 3. Now we have to determine, are they parallel, perpendicular, or neither? Again, these L's say that the slope of a parallel lines have to be exactly the same. And you might say, hey, I already know they're exactly the same. Perpendicular are going to be, change the sign and flip it, they're negative reciprocals, and neither is anything else. Since these are exactly the same, they're parallel. Don't worry, there will be some neithers on homework, quizzes, tests, midterm, final, all that stuff. Chapter 3, Section 5, Questions 4 and 5. You're going to be writing the equations of lines in up to 5 forms. Now, if you look in the textbook, they don't have this last form. but it's in your college class, so we figured why not teach it to you now. So, point slope form, we were just going over point slope form. Slope intercept form, we've been going over for a while since chapter 2. Function notation, changing the y equals into an f of x equals. But notice the mx plus b is the same. We have been dealing with that since the section on our standard form. And then here, standard form, x's, y's equals number. And all you do for general form is take this constant here, put it to the other side. Now, some students said, hey, if it's a positive c here, why is it also a positive c here? It's because it's just a variable representing a number, and if this number was negative on this side, it would be positive on that side. If it was positive here, it would be negative here. But the a, b, and c here are different from the a, b, and c here. They're just showing you where the numbers go. It goes x's, y's equals number, x's, y's number equals 0. Now, something to remember about these last two, we had rules about it that they're going to have no fractions or decimals, and a is positive. So make sure you know about that. But we're going to give you some information about a line. Sometimes we can give you 2 points. You'll have to find the slope and use one point to find this, and then we can change it into all the rest of them. We could give you a slope and a point. You can find this and then find all the rest of them. So there are many different ways of doing them. We can also give you a line that it's parallel or perpendicular and a point, and you can find all of these. So there's many ways of doing this, and you do want to practice finding all of those.